So we're now looking at the payoff phase of glycolysis. We already talked about the first phase, and we have our end product, which is glycerolaldehyde 3-phosphate. But one important thing we should note is that in the process of having this glycerolaldehyde 3-phosphate, when aldolase split them into dihydroxyacetone and glycerolaldehyde 3-phosphate, dihydroxyacetone was converted to glycerolaldehyde 3-phosphate. So meaning we not only have one glycerolaldehyde 3-phosphate, but we have another one coming from dihydroxyacetone. So it is very important to note throughout this process that for each molecule, it's 2 multiplied by 2, simply because we have 2 molecules of glycerolaldehyde 3-phosphate. Sorry. So it is 2 glycerolaldehyde 3-phosphate. So in this process, again, we have several enzymes, and they all have different roles to play. And if you can notice in the drawings, they look much more meaner than the other ones in the first phase. So the first enzyme we have is what's known as glycerolaldehyde 3-phosphate dehydrogenase. Oh, I can't even write it down because of the space. Again, glyceroldehyde 3-phosphate dehydrogenase. What this enzyme does is what is known as oxidative phosphorylation. So this will do 2 reactions. So first of all, oxidation. Second of all, phosphorylation. Oxidation of the glyceroldehyde 3-phosphate. Oxidation in this process will mean the loss of this hydrogen atom. And when we lose this one, it is left like that. But one important thing to note is that this is where NAD comes in. So NAD plus comes in, it will combine with this hydride ion to form what's known as NADH. So again, NAD form NADH. And then again, we said it is times 2. So it means it is 2 NAD forming 2 NADH, and we again invest in 2 hydrogen atoms in the process. So I've talked about the first step, which is the oxidative part. So for the phosphorylation, what happens is that we are going to invest yet again another phosphate, because this will be left as CO, the negative charge here. But then again, there will be a phosphate that will come in. When this phosphate comes in, it will go and place itself right here. So what does this mean? It means now that glyceroldehyde 3-phosphate now has 2 phosphates. And again, like we said when we're in the first phase, when we're looking at these the enzymes and the naming of these substrates. So we have a phosphate here at carbon number 1, and another phosphate here at carbon number 3. So what we're going to name this new compound is 1/3-bisphosphoglycerate, meaning 1 here and here at the 3 position of the carbon. So 1,3-bisphosphoglycerate. I reached this point. I hope we all get it at this point. So again, glyceroldehyde 3-phosphate at this position 1 of the carbon atom, it is gaining a phosphate at this number 3 position. So 1,3 again. So in the second phase, we are now going to convert 1,3-bisphosphoglycerate into 3-bisphosphoglycerate. So in the second reaction, we're going to have an enzyme which is known as phosphoglycerate kinase come in. So what this guy does, because this is the payoff phase, it will now start producing the ATP that we want from the reaction. So the thing that will happen is that there will be a molecule of ADP. ADP meaning adenosine diphosphate, so meaning it has 2 phosphates attached to it. So there will be 1 phosphate here and another phosphate here. So it will not only get this, but it will also grab this one here. So when it grabs this one here, it will grab the phosphate off from this group. So once it gets this phosphate here, we're looking at the structure of a molecule, it will attach this phosphate here to the ADP molecule. So if ADP, meaning adenosine diphosphate, has gained a molecule of phosphate, it means it will now be known as ATP, adenosine triphosphate. So meaning it will now be this molecule with now 3 phosphates attached to it, right? And then in the process, the 1,3-bisphosphoglycerate is going to lose a phosphate at the carbon atom number 1. So the name is now going to change. It will now be 3-phosphoglycerate because of the same reaction that is going on now. So then again, for putting it in this form, we're going to say ADP to ATP. And then again, we went over this the first time around because it is 2 molecules of glycerolaldehyde 3-phosphate going through this reaction. It will be 2 ADP forming 2 molecules of ATP. So in the third reaction, we are going to have this enzyme here. This enzyme is known as the phosphoglycerate mutase. And to help you remember this enzyme a little bit better, I thought of the word mutate. And the first person that came into mind is the Hulk. The Hulk, being a green guy and obviously angry, so this is the phosphoglycerate mutase, this enzyme here. So what does this guy do? So what this guy does is simply rearrange the 3-phosphoglycerate into 2-phosphoglycerate. So this means that this phosphate here, it will move from this position of carbon number 3 onto this position of carbon number 2. Then again, from that, this phosphate will move from position number 3 to position number 2 on the 3-phosphoglycerate. So again, from position number 3 here to position number 2. So it's going to look like this. The simplified version, carbon number 1, 2. Oh, carbon number 3, 2. Sorry, rather. So this is 2-phosphoglycerate. In the structural form again, we're saying it is moving from position number 3 to number 2. So it will be here. So after this, we are going to have 2-phosphoglycerate. Now, an enzyme that is known as enolase will come into the equation. I don't know if you remember from the last video on the investment phase, when you see a guy like this with the sash looking like he's doing karate moves, this guy is responsible for cleaving molecules apart, right? But in this case, I drew him to sort of look drunk because of the purpose and what he does. This guy is known as enolase. And an important part to remember is that from your organic chemistry, if you can remember accurately, an enol is defined as, when you have this carbon structure, it is simply defined as, when you have 3 carbon structures like this, is a double bond between the 2 carbons and the presence of an OH, which is an alcohol group. This is an enol. But in this case, instead of having the OH here, we have instead the pyruvate group. Oh, not pyruvate, sorry, the phosphate group. And it's because of this reason we are going to call it phosphoenolpyruvate. Yeah. So the enolase, what it does is that it will cleave off this part here, the OH here, the alcohol group. It will cleave off the alcohol group and leave it open, forming a double bond here, and it will now be known as the phosphoenolpyruvate. So the last step in the pair phase is catalyzed by pyruvate kinase. what does pyruvate kinase do? So in the pale phase is different. So after the formation of phosphoenolpyruvate, the thing is that we're losing an OH, and this OH, it will be lost in the form of water. So at this point, we're going to say there'll be loss of H2O. But then again, we said because of there's two glyceraldehyde phosphate, glyceraldehyde 3 phosphate, sorry. So I mean it'll be two H2O molecules lost at this point in time. And now the last phase of this reaction, in the pale phase, will be catalyzed by the enzyme known as pyruvate kinase. What pyruvate kinase does is sort of a similar thing, well, almost the same thing as what happened in the formation of the 3-phosphoglycerate. So what it does again, an ADP molecule, again ADP having 2 phosphate molecules, it will get the phosphate here and bring in the ADP molecule. So meaning what will now form is ATP with 3 phosphates attached to the molecule. Again, ADP form ATP. Again, not forgetting that it is 2 molecules involved. So again, 2 ADP form 2 ATP. So that marks the end of the pale phase. In the subsequent videos, we're going to talk about the fate of pyruvate, what happens to pyruvate when there's oxygen and when there isn't oxygen. So with that said, I hope I did not lose you in the video. I hope you understood something, and I hope you like it. And if you understood something, make sure you like, share, and subscribe. Even comment on more content you would like to have in the near future, because we make content based on what you need. So with that said, Dr. H with Tutorials on. Thank you.